Hey guys, how's it going? This is Carl, and this is problem number 10. We'll just go ahead and jump right in. Every year, a magazine lists the 100 best companies to work for, based on criteria such as pay, benefits, turnover rate, and diversity. Of the best 500 companies to work for, 186 experienced double-digit job growth, 194 experienced single-digit job growth, and 120 experienced no growth or decline. And a closer examination of the top 100 showed that 38 had job growth in the double digits, 43 in the single digits, and only 19 with no growth or a decline. Is there anything unusual about job growth among these top 100 companies? Now, part of it is we're going to select the appropriate procedure, and that's part question A. The appropriate test would be a chi-square test, or for goodness of fit. This test is kind of whether two categorical variables are independent of each other and examines the distribution of counts for one group of individuals classified according to both variables. So that's what the chi-squared test. Question B, check the assumption. The assumptions and conditions for a chi-squared goodness of fit are the counted data condition, the independence assumption, the randomization condition, and the expected self-frequency condition. For the counted condition to be met, the data must be counts of categories of a categorical variable. And since the data are counts, as we've shown, this is satisfied. For the independence assumption, the counts in the cells should be independent of each other, but if the data are a random sample, just check the randomization condition. The randomization condition requires that the individuals counted in the table should be a random sample from some population. Note, in this case, the conclusions don't need to be generalized, thus a random sample is not required. So what does that mean? So when it says that the conclusions don't need to be generalized, is that we're just ascertaining anything unusual. We're not necessarily comparing a random sample to this. We're actually comparing the top 100. There's nothing random about it. The expected cell frequency condition says that the expected value for each cell should be at least 5. To determine if a condition is met, first, compute the expected value for each cell. Note that the expected counts come from the predicting model, which in this case is the distribution of the top 500 companies. So what does that mean? What we're doing right here is we're testing out the proportion of the top 500 with no digit, with double digit, with single digit, and with no growth. And all this is we're taking the value, the one, like for instance, for double digit, the 186 divided by the total, the top 500 companies. So 186. Where does that 186 come from? If you remember from the question, it's right up here. 186 experienced double digit. 194 experienced single digit, and 120 experienced no growth. So these are our values. And same thing for here. The expected value for each, the expected count for the top 100 that had double digit. It's the same thing. What's the difference between these? This is the observed and this is the expected. Observed, top 500, same thing, 120 divided by 500 as we noted. So we're applying that in these cases, the top 100. So the top 100 times our probability our proportion rather, calculated here. So we're really taking this, multiplying by 100 to get these values, these expected values. And you can see here 38, all it is our 0.388 times 100. 24 is the same thing. So you almost just based on, because of the size of the group that we're dealing with, it's pretty easy multiplication for this case. So since each expected value is greater than 5, the expected self-frequency condition is met for the chi-square. Part C is state the hypotheses. The null hypothesis assumes the default. It always assumes the default, that the status quo is true, that there is no measurable, there's no correlation, there is no link, they're independent of each other. Alternatively, the alternative hypothesis is that the distribution is not the same as the distribution of the 500, that there is something unique in distribution-wise between the top 500 compared to the top 100. So those are our hypotheses. And part D is test this. So we have our observed right here, as we've mentioned, as you can see, and expected right here for the top 100. Where did these 43, 38, 19? Remember, we go to the top, go to all the way up to our question itself, and you can see the top 100, 38, 43 single digit, 19 no job growth. That's where we got these values that we're using in part D. Expected, same principle, our expected values. So remember, in essence, what we've done is we've used the proportions from the top 500 and we're applying them to the top 100 to examine them, to see if there is something unique about this top 100. So we're using our expected values that we calculated up here, and we're getting a residual of 5.8, negative 0.8, and negative 5. What's the residual, you ask? Well, it's the observation minus the expected, the observed minus the expected. So as you can see, just 43 minus 37. Same here, 38 minus 38.8, negative 8.8, and then the same here, negative 5. And if we go here, we're going to square our residual to get 33.64, 0.64, and 2.5. And then we're going to do that again here to get basically our square, chi-square, where it's the observed minus the expected squared, or the residual squared, divided by the expected. And that's really what we're doing here with these values. And then we're adding them up. So our total chi-square is 1.96, which is basically the sum of each individual chi-square you can see here. Our degrees of freedom, remember it's based off the number of rows. It's 3 minus 1 because there's 3 pieces right here. And the p-value, remember the p-value, we're using the chi distribution function. And as we're entering it, remember, you can see x, what's our x here? Well, we calculated that. This is our chi-square, 1.96. And the degrees of freedom, we've done it here, too. So as you can tell, that's our chi-square. So if the p-value is less than a reasonable significance level, reject the null. So, and remember, a good way to kind of help you out with this, if you always get confused about testing this out, because sometimes eyeballing, if you get small values, or you're doing several tests at a given time, it's really good to kind of get a good harness on what this is. So 0.05. So remember, if p-value is less than this, so we can actually make an if statement to help us with this, just for the sake of practice in Excel. So the logic test, if this value, 0.05, is less, reasonably less, or sorry, I mixed it up. If this value is less than a reasonable significance level, so if 0.37 is less than 0.05. Now we know it's not, but it's good to practice in Excel. So if it's less than, remember it's less than this, then we'll go ahead and type. Now remember when you're doing text, it's there. So if it's less than, reject the null. Reject the null. I know you can probably guess what the answer is already, but it's always good to practice. And if not, we fail to reject. So it's always good to practice this. So we'll go ahead and clean that up and see we have our statement. And as you can tell, we failed to reject. So that's what it is. That means that there is something unique. What that means that the distribution of the top 100 companies is not the same as the distribution of the top 500 companies. So that's really what we've just proved. So we hope this helps. Just let us know if you have any questions along the way. Thanks so much. Bye.